Hi, my name is Michael Knight. Welcome to my channel. Today we're going to be working on series parallel combination circuits. A lot of times it's better to redraw them, especially starting out. Redraw them where they make a little more sense because they can be drawn kind of weird. They're kind of putting everything together in the smallest amount of room they have, and sometimes we need to redraw it so that we can understand what's series, what's parallel, and so forth. So today that's what we're going to do. All right, so our first problem we're going to do here is I'm just going to draw real briefly here what they have in a small diagram, and then we'll redraw it a little bit. And so they've just got something like this drawn right now. And they have, let's see, this is R1, R1, R2, R3, R4, R5. So there's just 5 resistors here. And this is not too complicated, but we're going to redraw it anyway. So how I would redraw this is I would just come up here, and then right here, this is called a node with these hooked together. So I have R2 going down this way, is the way I'm going to draw it. And then I have this going on straight, and then I have another node, and it's splitting. So I'm going to go, so those are really just in parallel right here. And that's R3 and R4. So if I look at that, this is just a piece of wire. So this would be the same as if it was hooked up just like I have it here. Then from the bottom, R3 and R4 come back together here. And then they go to R5. And I'm just going to draw it like that. And then R5 comes back to the bottom of R2. So those are going to come back together right there. See? R5 and R2 come back to this node. And then we have R1 right here. It's going back to there. And this is R1. So now it's redrawn. So I can pretty easily see this is series. And these are all in parallel with this one, but these are in parallel. So the way to work these is what we do is we collapse it down and then we expand it back out. So let's get our information on here first. This is 24 volts. And then this is 4 amps. I'm going to circle those. And that's ET. I'm going to go ahead and put IT equals RT equals and PT equals. Go ahead and probably a good idea to get in the habit of doing these, writing all the abbreviations on here so you'll know what everything is. So this is E1, I1, R1, and PR1. Really, it should be, oops, IR1, ER1, R1, and PR1, like that. That's the best way to do it. And then we'll do same thing with R2. We'll do ER2, IR2, R2, PR2. And that way we'll start really getting the terminology down. We'll do R4 the same way. ER4, IR4, R4, PR4. Then we'll do R3. And it doesn't matter what order they're in, really. It's just the way when I drew it to keep everything where it looks the same. Sometimes you can turn the circuit up on edge too, and it looks a little easier to solve. And sometimes once you get the hang of it, you'd probably be able to solve it without redrawing it. But I found that most people do a lot better by redrawing it, especially starting out. And you have some people that don't have to draw them at all, but they're the ones that usually make the most mistakes. All right, so we've got our information here. B is 12 volts. 2 is 12 volts. And I'll circle the information that we're given. D is 6 ohms. Okay, so let's see. 12 volts. This is 4 amps. R1 is 4 amps. And 3 is 0.75 amps. 0.75 amps. Oops, lost my decimal. 0.75 amps, which would be equals 750 milliamps, would be a more correct way of writing that. 6 ohms. So this is 6 ohms. And then 4.5 volts. 4.5 volts. And we'll circle that. Okay. And I think we're ready to work it here. All right, so if we have 4 amps going through this series part, this current goes through here and then it splits up. Or we can go from this direction, it splits up, comes down, and it all comes back together here. So 4 amps is the total amps. Whatever runs through this resistor has to be the total because it's got nowhere else to go here. Once it gets here, it splits. And you can go forward, you can go either direction. You can go this way or you can go that way. It really doesn't matter. So we know our total amps is 4. So once we get 2 things, we can solve everything, right? So we have E and I. E divided by I equals R. So we get total resistance right there real easy. And I'm just going to use a calculator because it's here. 24 divided by 4 equals 6 ohms. 6 ohms of resistance. And then we can do power. P is I times E, which would be 24 times 4. 24 times 4 equals 96. And power is measured in watts. 96 watts. Okay? So now let's see what we can get. So typically what we do is we're going to start here. If we can, let's see where we can start. We got 4.5 volts here. We have 12 volts here. So we can do this. This would probably be the next easiest thing. Every path has to drop all the voltage. So if we're dropping 12 volts here, that means we have to be dropping 12 volts here. Because 12 and 12 is 24, and that's the total. In this path here, we don't know what the voltage is. We're dropping 4.5 there, though. So if this is dropping 4.5, and this is dropping 12, that's 16.5. So we can take 24 minus 16.5. So now we're going to do this path here. This path right here. Let's just do this one right here. That's a path. We're dropping 12 volts, 16.5 volts. Then the rest is right there, 7.5 volts. That's the way voltage works in parallel or series. Every path has to drop all the voltage. So this path here, through that resistor and that resistor and that resistor, also has to drop 7.5 volts. Now, another thing that you notice is in parallel, you have a parallel branch here. They're going to be seeing the same voltage because they're parallel. So they see the same voltage. So now we have the same voltage for everything. We can figure something else. So we've got two of each of these. So we could solve these parts of the problem all together right now. So 7.5 volts and resistance. So E divided by R equals I. So 7.5 in my calculator divided by 6 ohms equals 1.25 amps. 1.25 amps. A little crowded there. All right. Now this one's different though, isn't it? It's got 0.75 amps already. So let's go ahead and finish this one. We've got 1.25 amps. So for power equals I times E. So we'll do I times E. We've got I in the calculator times 7.5 equals 9.375. 9.375. And that is watts. All right, now let's go ahead and solve this one real quick. So we've got voltage and current. E divided by I equals R. So let's go back to 7.5 divided by 0.75. Now I usually take it back to base to do my calculations. Once you get used to it, you can work with milli, but start out with base is the easiest way. And it equals, and that's 10 ohms. Now I'm going to go voltage times current to get my power. Voltage times current is 0.75 times 7.5, 5.625. 5.625 watts. All right. Now, the next thing we have is whatever current goes here and the current goes here, it comes back together, and that's the current that's here. So these two currents added together would be this current. So 1.25 times plus 0.75 would be 2 amps, right? So I've got 2 amps coming down here, and it's going to be 4. So I've got to have 2 amps coming from that way, 2 amps coming from that way. So that means that's got to be 2 amps. And that's how you solve it. You have to use voltage and current, and you alternate back and forth to solve the problem. All right, so 12 divided by 2, E divided by I will give you R. So that would be 6 ohms. And then 12 times 2, I times E will give you 24 watts. Right? Okay, and so that solves that one. Oh, we got to solve this one. We didn't finish this one. So we have 4.5 times 2 would be what, 9 watts? 4.5. 9, and then we have 4.5 divided by 2. E divided by I gives you R. Divided by 2 equals 2.25 ohms. All right, that one's solved. Now let's solve this one. 4 times 12 is 48 watts. 12 divided by 4 is 3 ohms. Should be easy enough. All right, so now let's check ourselves. Each path has to drop all the voltage, so there's 12 and 12 is 24. There's 7.5, 4.5 is 12 and 12 is 24. 7.5, 4.5, 12 is 24. So the voltage all add up, and no matter which path you go, the voltage will add up to the total. So that's good. The current, 4 amps. So every path, so you got 2 amps here. You got 1.25, 0.75, that will give you 2 amps here. And then 2 amps coming through here, so that's right. It comes together there at 2 amps. 2 and 2 is going to give you 4 here, which is the total. So that all looks good. All the paths add up to the total. Resistance is a little trickier. We did that, I think, already, but let's do the watts. Watts, no matter if it's series or parallel, no matter which one, you just add them up. All you have to do is add them all together. So let's just do that. Let's do it on the calculator. 5.625 plus 9 plus 9.375 plus 24 plus 48 equals 96 watts. So we're good. So that all works out. So that's how you solve a series parallel circuit, a combination circuit is what we call them. And like I said, the easiest way, and this one's not that complicated, but you know, as they get more complicated, if you redraw them like this, it makes them a whole lot easier to solve.